Hi everybody, and once again welcome to Pankaj's Echelon Tutorials. In this today's session, we are going to talk about this IGCSE curriculum, the 10th grade, and we are going to deal with the subject International Mathematics, whose code is 0607. And the topic that we are going to start discussing is probability. And the reference book that I'm going now onwards I'm going to refer to is the David Renner's book, but this is a new edition. I mean the newer book, that is 2013 edition. Okay, so till now I was referring to a very older edition than this one, but now onwards I will be using this David Renner's 2013 edition, which is the latest one, I suppose, right? Okay, so to understand this probability and the concept of entire probability, okay, we will have to start with the concept of relative frequency to estimate probability. So probability is a very vast topic. Okay, it's it has a lot of things into it. But then to start with, if you want to start from the scrap, you must first try to understand what is relative frequency, because relative frequency is something which is very close to probability. In fact, relative frequency is something that leads to probability. That way you can say. So let us start with relative frequency and its connection with the probability. Okay. So the first thing that you should know is understanding relative frequency distribution table. Now for this, let us consider this example. Suppose certain values are given to you over here: 2, 5, 3, 4, 7, 2, 5, 8, 3, 2, 2, 3, 2, 5, 5, 4, 8, 5, 2, 8. These are the values given to you. Okay. Now from these values, what I can do is I can see the values that I've written over here are right from 2, 3, 4, 5, 6 is not there in this. Okay. So I have not written the value 6. But you have 7 and then you have 8. So all the different values that are included in this data I have written here as a column of values. Then second column I have tried to write the frequency. Okay, so what is the frequency? How many times that particular value is repeated in this table, in this observation table? So you can see that 2 is repeated 6 times. So if you count this is 2. Okay. So 1, 2, 3, 4, 5, and 6. So 2 I can see in this table, it is repeated 6 times. So frequency of 2 is 6. Similarly, 3, if I count, this is 3, 1, 2, and then 3. Okay. Any more 3 I can see? No. So 3 is repeated 3 times. So the frequency of 3 is 3. Same way, frequency of 4 is 2, frequency of 5 is 5, frequency of 7 is 1, and frequency of 8 is 3. So this is the frequency column that I have made. Okay, first column was the value column, second was the frequency column. One more thing I can do, I can add up all these values of the frequency, that is summation of the values of this frequency column, and that it works out to 20. Okay, now this 20 happens to be the number of observations in this table as well. Okay, so this 20 is known as something called the number of trials, which is denoted by n. So this n is the number of trials. Okay, or you can say that the number of total observations. Okay, that also you can say. So number of trials you can say, or number of total observations. So that is denoted by a capital N, right? So that is the frequency column. Now, what is relative frequency? Relative frequency is frequency divided by this total number of trials. So, one by one, if you take the frequency, so 6 if you take, and if you divide by 20, you will get the answer at 0.30. So, this is the relative frequency of getting a 6. Okay. Same way, 3 divided by 20, which works out to 0.15. This is the relative frequency of 3. Same way, relative frequency of 2 will be 0.10. Relative frequency of 5 will be 5 upon 20, which works out to 0.25. Then relative frequency of 1 will be relative frequency of, I'm sorry, relative frequency of 2 will be 6 upon 20, which is 0.30. Relative frequency of 3 will be 3 upon 20, which is 0.15. Relative frequency of this 4 will be 2 upon 20, which is 0.10. Relative frequency of this 5 will be equal to 5 upon 20, which is 0.25. Okay. Relative frequency of this 7 will be 1 upon 20, which is 0.05. And relative frequency of this 8 will be 3 upon 20, which is 0.15. So this is how you have to calculate the relative frequency of each and every value. Okay. So here I have written relative frequency of 4 is 0.10. Can you see this 4? The relative frequency is this one, 0.10. Then relative frequency of 5. So this is relative, this is 5. So relative frequency of 5 is 0.25, right? And then relative frequency of 8. So can you see this 8? So relative frequency of 8 will be this 0.15. So this is how you have to make the relative frequency column. And one more thing, when you add up all the relative frequencies in this column, you will always get the sum as 1. Okay. So the summation of the relative frequencies of all the values will always give you the answer as 1. Okay. So this is the concept of relative frequency. So you take any values, small, big, okay. You find out the frequencies and then you find out the relative frequency. You will always find that the summation of the relative frequencies will always be equal to 1. Is that clear? So that is what is the meaning of relative frequency. Okay, now let us go ahead and see what way you can make a formula out of it. So just now I told you how this relative frequency table is made, and in the process I told you how to get the relative frequency. Okay, so to get this relative frequency, what you did, you divided frequency by the total number of trials, isn't it? So this relative frequency is equal to S upon N. Now this is a formula that you should try to understand. Okay, relative frequency is equal to S upon N. Now don't worry about what is this S and N. You should know what actually I mean when I say S, what actually I mean when I say N. That you should know. So this S is nothing but the frequency. Okay, from the frequency distribution table, whatever frequency values are there, that is nothing but the S. Okay, and what is this N? N is the number of trials. That is the sum of the frequencies, isn't it? So relative frequency can be written as S upon N. If you arrange this formula, you get this formula, that is S equal to N into relative frequency. And if you again rearrange this formula, you will get N is equal to S upon relative frequency, isn't it? So these three formulas, 1, 2, and 3, you can shuffle the concept and make these three formulas. And these three formulas will be very useful in dealing with the problems. Okay. Now these three formulas are nothing but arranged formula of this particular formula. The main formula is this one. Relative frequency is equal to S means the successful outcome. That is, in bracket I have written S. Okay. Successful outcome divided by number of trials, that is N. Now remember here, this relative frequency is a concept for which you will have to perform an experiment. Okay. Without performing an experiment, you can never ever get a relative frequency. What I mean to say is, you'll have to literally, throw a dice, or you'll have to literally toss the coin, many number of times. Okay. And you'll have to keep on monitoring what observations you are getting in every trial. Okay. And then you'll have to find out that what is the successful outcome. Suppose you are interested in getting a 6 while you are throwing a dice. Then in a throw of say 25 dice, it means if you are throwing dice 25 times, out of the 25 times, how many times you are getting that 6? Okay, that is your S. That is your successful outcome. Okay, and number of trials will be 25. Okay, so out of 25, how many times you got that 6? Okay, that is telling you the relative frequency. Is that clear? Now, relative frequency approaches or comes closer to the probability as the number of trials increases or becomes very high. So, if the number of trials is 25, relative frequency will not be that close to the probability. But as the number of trials increases from 25 to say 100, or 100 to from 100 to say 300, okay, then what will happen? This relative frequency and the probability, these values will come closer to each other, okay, or they will be matching. And a stage will come when the relative frequency becomes constant. Okay, so when the relative frequency becomes constant, that is the relative frequency is can be treated as the probability. So probability of something can be equal to the relative frequency of that something, provided the relative frequency has become constant. It is no more increasing. Okay, it has become constant, and this happens when the number of trials is increased. Okay, so this is the concept, and this is the thing that you should always remember. You should keep back of the mind. Relative frequency and probability, the connection is relative frequency will be equal to the probability, provided the n, that is the number of trials, is very high. Okay, now let us try to understand this by an example of a dice. Now suppose I have a dice and I throw that dice. So the sample space will be 1 2 3 4 5 and 6. This is the sample space, right? So uh, sorry, the sample space is 1 2 3 4 5 and 6. Now n of s, that is the number of elements in this sample space, is 6, because you can see 1 2 3 4 5 and 6, there are 6 elements, so n of s will be 6. Suppose the event that we are interested is the event that we are interested in is getting a 5. So event is getting a 5. N of E will be what? What is the event? Just getting a 5. So how many elements are there in this set E? Just one element. Okay. So N of E will be 1. Okay, not 5. 5 is the element we are interested in, and that is only a single element. So N of E will be 1. And probability of E will be equal to N of E upon N of S, which works out to N of E is 1 and N of S is 6. So it will work out to 1 by 6. This is the probability concept. Okay, and this concept is known as theoretical probability. Now, in arriving at this figure 1 by 6, that is probability of getting a 5 is 1 by 6, we did not perform any experiment. We did not do anything we did not conduct any practical sort of thing. We did not throw the dice a number of times. No, from the theory itself, we know the sample space is this, we know the event is this, the number of elements in the event is this, and when we divide the two, we get the probability. So no need of doing any experiment. So such a method or such a way of arriving at the probability value is known as theoretical probability. Okay, now you will notice that probability of each and every single outcome of this particular experiment. Now what is this experiment? This experiment was throwing a dice, a single dice. So when you throw a single dice, it's a random experiment. So you can always get 1, 2, 3, 4, 5 or 6, anything. You cannot say. So it's a random experiment. The result of the experiment, which is not predictable, is known as a random experiment. So this is a random experiment. But the probability of getting a 1 or a 2 or a 3 or a 4 or a 5 or a 6, each of the probability getting the probability of getting each of this, okay, each of this event is 1 by 6. Okay, if that is the situation, we say that this is called that the events are equally likely. Okay, so these events, that is 1 2 3 4 5 and 6, these events are known as equally likely events. Okay, or in other words, they are known as exhaustive events. Okay, so remember this: what is equally likely events, what is exhaustive events. In the future, these terms are going to pop up. Okay, so that was the theoretical probability, how to calculate, how to get the theoretical probability of a dice. Now suppose I want to arrive at the probability or the relative frequency in the same experiment, that is dice experiment. So what I will do is, now what I'm doing is I'm taking a dice and I'm throwing it 25 times. Okay, I took a dice and I'm throwing it 25 times. Every time that I'm throwing a dice, I'm recording what values I'm getting. So maybe I will get 1 2 3 4 5 or 6, right? So in 25 throws, I saw that I'm getting 1 7 times. Okay, so variable, this value will be 1 and frequency is 7, right? And I saw this in this 25 throws, the 2 I got 3 times. Okay, 3 I got 2 times, 4 I got 8 times, 5 I got 4 times, and 6 I got just once. Okay, so this is how the frequency table was generated. Values I have written here 1 2 3 4 5 6. Frequencies I have written here and the summation of this frequency should always work out to n. So this is your n, okay, which is nothing but 25. So this 25 is your n, which is also known as the total number of trials, right? Now, the relative frequency will be frequency divided by the n, okay. So 7 upon 25 is the relative frequency of getting this 1. Then 3 upon 25 is the relative frequency of getting this value 2. Then 2 upon 25 will be the relative frequency of getting this value 3. Then 8 upon 25 will be the relative frequency of getting this 4, and so on and so forth. So I've written here relative frequency of 5 will be equal to, so you can see from here, this is 5, okay. So relative frequency of 5 will be this 4 divided by this n, okay. So 4 upon 25, which works out to 0.16. Now remember here, I have taken frequency divided by n, okay. Now this relative frequency is nothing but s upon n, okay. And I told you this s is nothing but the frequency only, okay. So now you will be able to identify what is the meaning of this S. The successful outcome is the number of successful outcome is your S. So in this case, how many times you got 5, okay, successfully in this 25 throws, okay. So 5 you got how many times? 4 times. So that is why this S will be 4, okay. And that is why you can see the 4 over here. And this N is the total number of tries, which is nothing but the total of the frequency, that is 25, and it is given here. The dice is thrown 25 times. So that 25 is your N. So your RF for 4 happens to, RF for 5 happens to be 4 upon 25, okay, which is 0.16, isn't it? Now, you will see that the probability of getting a 4, the theoretical probability, is 1 by 6, which is also equal to 0.16. So can you see, in this case, when the number of throws is 25, the number of trials is 25, the probability of getting a 4 is 0.16, and the relative frequency of getting a, I'm so sorry, this relative frequency of 5 and this probability of 5, okay, probability of 5 is also 1 by 6, isn't it? So both these values are equal. So you can say that probability of getting a 5 is same as relative frequency of 5. Okay. But if you check for the 4, relative frequency of 4 is 0.32 and the probability of 4 is how much? It is 1 by 6, that is 0.16. So this is not matching. Probability of 4 and relative frequency of 4, these are different. Relative frequency of 4 is 0.32. So there's a difference between these two, okay. But now if you increase this number of trials from 25 to maybe 100 or maybe 200, then even this difference, will come down, okay. That is what I want to say. So ultimately, relative frequency of some value x is equal to the probability value of that x when n is very high. Now, this is the concept that you should understand. This is the connection between relative frequency and probability. And this, in probability language, it is said that the relative frequency is the estimate of the probability, or the probability can be estimated by relative frequency. And now in the next video, I will be giving you some numericals based on this particular concept, and you should be able to use that formula very nicely in those questions. And once this concept is over, then we can proceed with the probability ka real concept. Okay, that is classical probability and other things that will come in probability. But this was the base, the founding stone of probability, something which was related to relative frequency. Okay, and that's all for today's session. And if you happen to like my video, please subscribe to my channel. You can like my channel, and yeah, that will motivate me to make more such videos. Okay, so that's all for today. See you all. Goodbye. Take care, all of you.